All right, and now at this point, we're going to continue on and we're going to enter into probability. We're going to spend a little bit talking about probability. So probability is the mathematical description of randomness and uncertainty. It is also thought of as the chance or the likelihood that something happens. So in probability, we have experiments. An experiment in probability is a situation involving chance or probability that leads to results. So an experiment is anything that you do where there is chance involved. So when we roll a die, that could be a probability experiment because it is up to chance as far as what number comes up. The outcomes are the results of a single trial of an experiment. So a trial is a single repetition of the experiment. So if I continue with the rolling a dice example, it's one of the easiest examples to talk about. One roll of the die constitutes a single trial. So the outcome of that trial would be what number I see when I roll that die. And depending on what you're talking about, you might have a different number of outcomes. So if I flip a coin, there are only 2 outcomes to that experiment, heads or tails. If I roll a die, a standard 6-sided die, there are 6 outcomes. So an event is one or more outcomes of an experiment. Typically, the event is what it is that we are interested in when we are conducting this experiment. So if I'm rolling a die and I'm playing some sort of game where I need to get an even number, the event is that I get an even number when I roll the die, because that's what I'm interested in. The sample space is the collection of all of the outcomes for the experiment. So the sample space for rolling a die would be the numbers 1 through 6. And then this last one, this P and then the A in parentheses, this is read as the probability that A occurs. And in this case, A represents our event. So I'm going to finally do a little bit of writing here. So A is an event. So if we were to be talking about the probability of rolling a even number when we were rolling a die, because that's what we needed for the previous example I gave, we would say, okay, the probability of an even number. So it's not P times an even number, it is the probability of rolling an even number, or the probability that we roll an even number. So there are 2 very, very important rules of probability. If you do not remember these 2 rules, this section, these subsequent sections, all of the stuff we do where we talk about probability could be very hard because of these 2 rules that you have to remember. And if you don't remember these 2 rules, it could cause some issues later on. I think I've driven in my point enough. All right, here we go. So the first most important rule to probability is that, not A, I don't want to say A. The probability of an event is always between 0 and 1. So probabilities are always going to be values between 0 and 1. 0 represents the probability that something cannot happen. 0 means it's impossible. 1, if we had a probability of 1, that means it's a certainty. It is guaranteed to happen. Okay? All other probabilities, when we talk about the probability of an event, they will always start with 0 point something because they're going to be between 0 and 1. We can also say that they're between 0% and 100%. But we don't typically report probabilities as percentages unless we've been explicitly told to do so. Probabilities are typically left in decimal form. So that's the first most important rule. The second most important rule is that the probabilities of all possible outcomes for an experiment sum to 1. So not only is the probability going to be between 0 and 1, but the sum of all of the probabilities for a given experiment have to sum to 1. So if I'm running an experiment where I'm flipping a coin, the probability that I get heads is 1/2. The probability that I get tails is also 1/2. Those are my two possible outcomes for my experiment. So if I add 1/2 and 1/2 together, I get 1. That is going to be true for all probability experiments. If you take all of the outcomes probabilities, add them together, they must sum to 1. If they don't sum to 1, then either something has gone wrong in your calculations of the probabilities, or you do not truly have a probability experiment. So this is our introduction to probability. We will continue on and actually start looking at some different ways to calculate probability in the next videos.